Welcome to the third and final lecture on sets. So, in the first two lectures we introduced the basic notions of sets and then we discussed some of the operations on sets and some properties on sets. Today we will do some problems on sets. Let me first recall, if n of A is the number of elements in the set A, then for given two sets A and B, the number of elements in the union is given by n of A plus n of B minus n of A intersection B. And also we have for three sets n of A union B union C, this is equal to n of A plus n of B plus n of C minus the number of elements in the intersection of any two. So, n of A intersection B minus n of B intersection C minus n of A intersection C plus the number of elements in the intersection of all three, A intersection B intersection C. Right. So, these formulas are very useful. Also, let me write for any sets A, n of A is n of A minus B plus n of A intersection B. This is because A is the disjoint union of A minus B and A intersection B. So, let us do some problems based on this formula. So, problem 1, suppose we are given n of A is equal to 6, n of B is equal to 4, then what is the minimum and maximum value of n of A minus B? So, we are given the number of elements in A and number of elements in B, and we want to write the number of elements in A minus B. So, we know that n of A is equal to n of A minus B plus n of A intersection B. So, therefore, n of A minus B is equal to n of A minus n of A intersection B. N of A is given to us, this is equal to 6 minus n of A intersection B. So, to find the minimum value of n of A minus B, we have to ask what is the maximum value of n of A intersection B, and the maximum of n of A minus B will be when n of A intersection B is minimum. So, we know that A intersection B, since A intersection B is a subset of B, this implies that n of A intersection B is less than equal to n of B, which is given to be equal to 4, right. So, number of elements in the intersection of A and B cannot be more than 4. So, n of A minus B is greater than equal to 6 minus 4 which is equal to 2. So, this is the minimum value, and for the maximum value we have to ask what is the minimum value that A intersection B can take. So, given that A and B are any two sets, it is possible that A intersection B is the empty set. So, also if A intersection B is empty, then n of A intersection B is equal to 0. So, therefore, the maximum value of n of A minus B, this will be equal to 6 minus 0, which is equal to 6, right. Because if A and B are disjoint, then in that case the number of elements in A minus B is same as number of elements in A. So, the next problem, this will involve 3 sets. So, suppose there are 60 people, out of these 25 read newspaper H, 26 read newspaper T, and another 26 read newspaper I. So, we have 3 newspaper H, T and I, say Hindustan Times, Times of India and Indian Express, and we know that 25 people read the H, 26 read T, 26 read I, and we are also given 9 read both H and I, 11 read both H and T, and 8 read both T and I. Also, we know how many read all 3. Finally, 3 people read all 3. Now, what do we have to find? Find, first one is number of people who read at least one of the 3. And second, find the number of people who read exactly one newspaper. Right. So, there is lot of information given. Let me show again. So, out of 60, 25 read H, 26 read T, 26 read I, 9 read H and I, 11 read H and T, 8 read T and I, and 3 read all 3. So, the best way to do this is you try to draw a Venn diagram. So, So, we have 3 sets H, T and I, and let us write the intersection of all 3. There are 3 people who read all 3 newspapers. Then we know that 11 people read H and T. So, the intersection number of elements in the intersection of H and T, that is 11. So, the number of elements in this part must be 8, because 8 plus 3 is 11. Let me use another pen. So, this part is 8, this is 3, and then the number of people who read H and I, that is 9. So, there are 6 people who read only H and I, but not all 3, and 8 people read T and I. So, 3 are who reads all 3. So, rest 5 read only T and I, right. And then you can fill in the other things also. So, number of people who read only H, we know that 25 people read H. So, here we have 8 plus 3 11 plus 6 17 who read at least 2 of the newspaper including H. So, the rest is 25 minus 17. So, this is 8 people who read H, only H, and then only T is 26. So, we have 8 plus 3 11 plus 6 11 plus 5 is 16. So, 10 are here, and then only I is 26. So, 6 plus 3 9 plus 5 14. So, 12 are here. Now, you can easily write what is being asked. So, the first one is number of people who read at least one of the 3. Either you can use the formula of this, means that we want what is n of H union T union I. So, we are given n of H, n of T, n of I and n of the intersections. So, you can use that formula and calculate, or once you have drawn this diagram, then we need to just add these numbers. So, this is equal to in H we have 25 plus 10 plus 5 plus 12. So, that is equal to 52. Or use n of H union T union I is equal to n of H plus n of T plus n of I minus n of H intersection T minus n of T intersection I minus n H intersection I plus n of H intersection T intersection I. Right. So, the first part you can use directly this formula and do, but it is easier if you draw the diagram. The other one is, it is asking the number of people who read exactly one newspaper. So, that number again is clear from this, right. There are 8 people, these are 8 who read only H, there are 10 who read only T and 12 who read only I. So, and there is nothing in common. So, 8 plus 10 plus 12, that means 30 people who read exactly 1. From the Venn diagram, number of people who read exactly 1, this is equal to 8 plus 10 plus 12, which is equal to 30. Right. So, this way you can quickly calculate these numbers if you have objective questions. So, next problem. Okay, let me write another problem based on these concepts. So, let n of A intersection B be x, n of A minus B, this is 6x, and n of B minus A is 8 plus 2x, and also given is that n of A is equal to n of B, and find x. Right. So, we are given the number of elements in the intersection and number of elements in A minus B and B minus A, and number of elements in A is equal to number of elements in B. So, to do this, we know that n of A is equal to n of A minus B plus n of A intersection B. So, this is equal to 6x plus x, which is 7x, and n of B is equal to n of B minus A plus n of A B intersection A. So, this is equal to 8 plus 2x and plus x. So, that is 8 plus 3x, and since n of A equal to n of B, we have 7x is equal to 8 plus 3x, and this immediately gives you x is equal to 2. Okay, here you could also use the formula for n of A union B and calculate it using n of A intersection B plus n of A minus B plus n of B minus A, and also using the other formula that n of A union B is n of A plus n of B minus n of A intersection B, and then equate them. But here if you notice this one, it is quicker to solve it this way. Okay, next problem. So, suppose %, Indians like apple and 82% like mango. Let x% of Indians like both, and find the minimum and maximum possible x. So, here what is given is if I write A to be the percentage of people who like apple, then n of A is 70, n of M is the number of people who like mango, this is 82%, and N of A intersection M is x%. So, what we know is that since N of A union M, this has to be less than equal to 100, right. The total 100% people are there. So, people who like either apple or mango cannot be more than 100%. So, we have N of A plus N of M minus N of A intersection M, this is less than equal to 100, which implies 70 plus 82 minus x is less than equal to 100, and this gives x must be bigger than equal to, this is 152 minus 100, 52. Right. So, number of percentage of people who like both apple and mango cannot be less than 52%. Now, how do we get the maximum value of x? Also, we know that A intersection M, this is a subset of A. So, therefore, N of A intersection M is less than equal to N of A, which is equal to 70. So, x has to be less than equal to 70% and bigger than equal to 52%. Okay, so next thing, let us recall this power set of this is all subsets of A, and we have seen that the number of elements in the power set of A is equal to 2 times the number of elements in A. So, the next problem, what is the number of elements in the power set of phi, where phi is the empty set. So, first of all you have to know what is the number of elements in power set of phi. So, this is equal to what? Since the number of elements in the empty set is 0, the number of elements in power set of empty set, this is equal to 2 to the power 0, which is equal to 1. Right. Empty set has only one subset, which is empty set. So, number of elements in the power set of empty set is 1, and then this will imply that number of element in power set of phi, this is equal to 2 to the power number of elements in power set of phi, which is 1. So, this is 2, and this will imply that number of elements in power set of phi this is equal to 2 square, which is equal to 4. So, this problem was just to recall the number of elements in the power set. So, this was our problem number 5. Let me do one more problem where we will use this number of elements in the power set. So, suppose we are given n of A is equal to some number m, n of B is n, and the number of elements in power set of A minus number of elements in power set of B is given to be 112, then find M and N. So, if you know the difference of the number of elements in power sets of A and B, we want to find the number of elements in A and number of elements in B. So, what is given here is we have number of elements in power set of A is 2 to the power m minus 2 to the power n, this is equal to 112. So, you might be thinking that we have only one equation and from here we have to find both m and n, but you can do it because, so this first of all implies that m is bigger than n, and then you can write this as we can take out 2 to the n common, and then we have 2 to the power m minus n minus 1, this is equal to 112. So, here note that we have taken out powers of 2 outside, and then the rest is 2 to the power m minus n, which is an even positive integer, minus 1. So, this part is an odd integer. So, what you try to do is just write 112 as product of, so this can be written as 16 times 7, which is equal to 2 to the 4 times 7. So, this implies n must be equal to 4 and 2 to the m minus n minus 1, this is equal to 7. So, that means that 2 to the m minus n is equal to 8, which is 2 cubed. So, this implies n equal to 4 and 2 to the m minus n is equal to 8, which is 2 cubed. So, this implies n equal to 4 and m minus n is 3. So, n is equal to 4 and m is equal to 7. This was problem 6. The next problem, we are given sets A and B. A is equal to 1, 2, 3 and 4. B is the set containing 2, 4 and 6. Find the number of sets C such that A intersection B is a subset of C and C is a subset of A union B. Right. So, we have to find all sets C such that C contains A intersection B and C is a subset of A union B. So, in this case A intersection B is equal to the set containing 2 and 4, and A union B, this is the set containing 1, 2, 3, 4 and 6. So, what we want is that, so we want 2, 4, this is A intersection B to be a subset of C, and this is a C is a subset of 1, 2, 3, 4 and 6. right. So, one way you can think of is you write down all the set C such that it contains the elements 2 and 4 and it is a subset of 1, 2, 3, 4 and 6, and that way you can count the number of such sets. But if these things have many elements, then that will be difficult. So, what we can do is here, so this implies C is equal to the set 2, 4 union with another set, let me call C prime, where C prime is a subset of 1, 3 and 6. So, you write C as disjoint union of, we know that 2, 4 must be there, and then it can have other elements which has to be from the set 1, 3 and 6, right. So, the number of elements in C, so therefore, number of C of such C is equal to number of C prime, which is a subset of 1, 3 and 6. And this, you know, this is nothing but the number of elements in the power set of 1, 3, 6. So, 1, 3, 6 has 3 elements. So, power set will contain 2 to the power 3, which is 8 elements. So, even if the sets had like 10 or 20 elements, you can do like this and calculate the number of set C. Okay, so let me write down one more problem. Let X be the set containing the numbers of the form 4 to the n minus 3n minus 1 such that n is a natural number, and Y is the set 9 times n minus 1 where n is a natural number. Then X union Y equals, we are given 4 choices. This is all of natural number B, this is equal to y minus x, C is this is equal to x, and D is this is equal to y, right. So, this is a multiple choice question and we are given the set x and y written in this set builder form, and we have to find what is x union y. So, to do such problem, you can try to write down the first few elements of x and y, right. So, if you see x, if I put n equal to 1, then this is 4 minus 3 minus 1. So, the first element here is 0. If I put n equal to 2, then 4 square 16 minus 6 minus 1. So, that gives me 9. And we put n equal to 3, will give 4 cube is 64 minus 9 minus 1. So, that is 54, and if you want you can calculate more. So, these are the elements of x, and y consists of, for n equal to 1 this is 0, then we have 9, 18, 27 and so on. So, y is clear, it consists of all multiples of 9, all non-negative multiples of 9. So, now if you see clearly, 1 does not belong to x union y. So, A is false. Also x union y we see that y is not a subset of x, right, because (18) belongs to y, but 18 is not in x. So, therefore, x union y is not equal to x. Right. This will be equal to x if y is a subset of x. So, C is also false, and B says that y minus x, can this be equal to x? So, this contains all the elements in y which is not in x. So, all the elements in y which is not in x. So, this is again not equal to x union y. This is because if you see zero, this belongs to x union y, but 0 is not in y minus x, because 0 belongs to both x and y. So, if you are doing this multiple choice question, only thing left is, so by elimination, D must be true if it is given that one of the statements is true. But let us try to prove this. So, what I want to say is that x union y is equal to y, which means that I have to show that x is a subset of y. Right. So, claim is x is a subset of y. This will imply that x union y is equal to y. Right. So, why is this? So, that is we have to show that 4 to the n minus 3n minus 1, this is divisible by 9 for all natural number n. So, we have to see that 4 to the n minus 3n minus 1 is divisible by 9 for every n. So, note that for n equal to 1, 4 to the n minus 3n minus 1, this is equal to 0, which is divisible by 9. And to actually prove this, we will need what is called principle of mathematical induction, which you will also learn in details in another chapter. But let me show you. So, suppose 4 to the k minus 3k minus 1 is divisible by 9, we will show that four to the k plus 1 minus 3k plus 1 minus 1, this is also divisible by 9. So, then we know that for n equal to 1 this is true. So, this will imply that it is true for n equal to 2, and then if it is true for n equal to 2, it will be true for n equal to 3. Hence, by induction it will be true for all n. So, why is this? So, let us write 4 to the k plus 1 minus 3k plus 1 minus 1. This can be written as, we can write as 4 times 4 to the k minus 3k minus 1. So, this gives me 4 to the k plus 1 minus 12k minus 4, but here I have 4 to the k plus 1 minus 3k minus 4. So, I have to add plus 9k. Now, what we know is that this part is divisible by 9 and this is also divisible by 9. So, the sum is divisible by 9. The next problem, let us take A to be the set n cube plus n plus 1 cube plus n plus 2 cube, where n is a natural number and B is 9n, n is an n. Then which of the following is or are true? First is A is a subset of B, second is B is a subset of A, third is A is equal to B, and D is A is a proper subset of B. So, B consists of all the positive multiples of 9, A consists of the sum of cubes of 3 successive natural numbers. So, if you see A, if I put n equal to 1, then I have 1 plus 2 cube plus 3 cube. So, that is equal to 36. So, and then you can find other one, this will be 2 cube plus 3 cube plus 4 cube and so on. So, the smallest number in A is 36. So, A is not equal to B, right, because B contains 9 which is not in A. Also, B is not a subset of A, right. So, B and C are false. is A a subset of B? So, the first element 36 is a multiple of 9. The next one again, if you calculate, you can see that that is also a multiple of 9. So, it seems like all these elements are, all these numbers n cube plus n plus 1 cube plus n plus 2 cube are multiples of 9. But how do we prove that? So, claim is n cube plus n plus 1 cube plus n plus 2 cube is a multiple of nine for every natural number n. So, you can simply calculate what is this n cube plus n plus 1 cube plus n plus 2 cube. This is equal to n cube. If you expand n plus 1 cube, this will give you n cube plus 3n square plus 3n plus 1, and then n plus 2 cube is n cube plus 6n square plus 12n plus 8. And then this whole thing is equal to 3 times n cube plus 3n square and 6n square. So, that is 9n square plus 15n plus 9. We want to prove that this is a multiple of 9. We already have this is equal to 9 times n square plus 1, and then we have 3n cube plus 15n. So, that is equal to 3n times n square plus 5, right. So, to show that this is a multiple of 9, you have to just see that n times n square plus 5 is a multiple of 3. So, another claim is n times n square plus 5 is a multiple of 3. So, if n is a multiple of 3, then of course, this is a multiple of 3. If n is not a multiple of 3, then n must be of the form 3k plus 1 or 3k plus 2, and then you just calculate. So, if n is equal to 3k, then this is fine. If n is 3k plus 1, then n square plus 5, this will be 3k plus 1 square plus 5. So, 3k plus 1 square plus 5, this is equal to 9k square plus 6k plus 6, and this is a multiple of 3. Also, 3k plus 2 square plus 5, this is equal to 9k square plus 12k plus 4 plus 5, which is again 3 times 3k square plus 4k plus 3. This is a multiple of 3 again. So, hence this n cube plus n plus 1 cube plus n plus 2 cube is a multiple of 9 for all n in n. So, we have the set A is a proper subset of B, hence A and D are correct. So, note that if A is a proper subset, that also means that A is a subset of B. Okay, so this completes the chapter on sets. Of course, you need to practice more questions on these things to be comfortable with these concepts. Thank you.